All right, so in this video, we're going to talk about a relative extreme values. Okay, your relative extreme values actually mean a couple things. Okay, it's like an umbrella of some things. All right, so relative extreme values, they're your relative minimums. Your relative minimums are going to be all your valleys. Okay, when it goes down, that's a relative minimum. All of them are relative minimums. Now, your minimum is the lowest of the valleys. Okay, there's only one minimum, but there can be multiple relative minimums, okay? A relative maximum is all your humps, okay? And then your maximum is your highest hump, okay? All right, so if you say you had this graph, let's see here, say you had a graph that looked like this. All right, so if you look, I really don't like this graph. Let's just erase it all. I need to start over. Okay, we have this graph right here. We got. All right, here we go. I like my sounds when I'm drawing. All right, so you have relative mins. Your relative mins are all of your valleys where you go whoosh, whoosh, your cups. So these are relative mins. So I have two relative mins, okay? Your min, like your ultimate min, is the lowest of your two relative mins. So this is your relative min. There's only one of those. That's your relative min right there, okay? Now, your relative maximums are all of your humps, your high points. I've got two humps, so I've got two relative maxes. And then your overall max is going to be your highest hump, which is right there, which I only have one of. Now, you have a total of 1, 2, 3, 4 extreme points, okay? So this plus this will give you your relative extreme points, okay? All right, so those are your definitions. Let's do some examples of what you're going to see in Desmos, okay? So the first thing you're going to see is that I need to plug my laptop in before it dies on me, because that would really suck. I think, all right, we did it. We're good. She's safe. All right, so the first thing we're going to talk about first is I want you to be able to find your max and mins with technology, okay? So with technology means that you're going to use Desmos. Now, when you're finding the maximum value, you're finding your y values. When you're finding the min, you're finding your y values, okay? We're not dealing with x's and y's when we're dealing with maxes and min values, okay? All right, so we have to go to Desmos to find these. Desmos is awesome because it's just a click point, okay? So I'm going to type this into Desmos, okay? We got y equals negative 1.5x squared minus 10x minus 12, okay? So it wanted me to find the maximum value. So find the highest y value is what that means. That is asking you to find the highest y value. It says round to the nearest hundredths, so hundredths is your second decimal place. So my highest y value is 4.667. When I round that, that's 4.67. So I'm going to type 4.67. Okay, let's do another one. This one wants me to find my minimum value. So it wants to know the lowest y value on this graph. The lowest y value. Okay, that is what it's asking, is the lowest y value. So y equals 2x squared minus 5x minus 3. So the lowest y value, rounded to the hundredths, so second decimal place, is going to be negative 6.13. Negative 6.13. And we're done. Let's get one that's not. Are they all squared? I think they're all squared. Okay? So that's what you're going to do on that one, finding your max and your min values with technologies. Okay? So determine the absolute minimum value of the function. So this one, am I still recording? Where'd it go? Sorry, my recorder went away. All right, so this one is determine the absolute minimum value. So again, what is the lowest y value here? How low does this graph go? It goes as low as -2. So my answer here is -2. Okay, let's do another one. Determine the absolute maximum value. So what's the highest y value? It's going to be 6. Okay? All right, so that's it for that section. So those are your two maxes and your minimums. Now we want to combine everything together and do determine key features of the graph. Okay? So the degree of the function, that is your humps plus 1. Okay? Humps plus 1. So I've got 1, 2, 3 humps plus 1 is 4. That makes this an even function. The leading coefficient, where does the graph end? It ends down here with the negative, so it is a negative. Zeros, how many times does this cross the x-axis? That's how many real zeros are there. Cross or touch. I cross it 1, 2, 3, 4 times. Okay, so I've got 4 zeros. Uh-oh. No, I don't want to pause. Go back, go back. There we go. We got 4 zeros. Okay. Next one, how many relative minimums? Relative minimums. How many valleys do I have? I only have one valley, so I only have one minimum. And we submit our answer. All right, let's do another one. Let me write on this next one. Come on, there we go. All right, so the degree. Your degree is your humps plus 1. Humps plus 1. So I've got 1 hump, 2 hump, 3 hump, 4, 5, 6 plus 1 will equal 7. So that is odd. So my degree is odd. Now, your leading coefficient. Your leading coefficient is where does your graph end? My graph ends right here. That's pointing up. So that's positive. Relative zeros. How many times does it cross or touch the x-axis? I got 1 cross, 2 touch, 3 crosses, 4, 5, 6. So I have 6 zeros here. Now, relative extreme values. The relative extreme values means all your humps. So I got 1, 2, 3, 4, 5, 6. So I have 6 humps, so I have 6. Whoops. Submit answer. We're good. Let's do another one. Okay. All right, here we go. So the degree is your humps plus 1. 1, 2, 3, 4, 5, 6 plus 1 equals 7. So my degree here is odd. Okay. Now, leading coefficient, where does this graph end? It ends pointing to the positive, so therefore it is positive. Okay. Next one, real zeros. How many real zeros are there? How many times does it cross or touch the x-axis? 1, 2, 3, 4, 5, 6, 7. So there are 7 real zeros. The last one says your relative maxes. That's your humps. How many humps you got? I got 1 hump, 2 hump, and 3 hump, right? So I only have 3 relative maxes. And then we hit submit, and you're done. Okay? So I hope this helps you out, guys, with this video. This is the last one for today.